Hey guys, my name is Tom. This is my friend here who's always smiling. He should be too. I'm sure you've got a reason if you think about it carefully. Now, in this video, I'm going to walk you using all these colors through another example of finding the slope of an inverse. So, now this is within the context of calculus. Okay, so this is a fairly tough topic for many students when they first encounter it in calculus. And we will take an approach based on pictures, as always. I am telling you, draw, draw, draw. The act of drawing clarifies things as nothing else seems to. So let's take a look at what we have. The function is this. F of x equals, and of course we can use whatever function we like. So why don't we use e to the x. Okay, so this is the basic exponential function, e to the x. The base is e. And the e has a beautiful interpretation, but that's for another video. Now let's take a look at what we have. First, we will begin by drawing a picture of this function. So let's take a look. We draw an xy coordinate system, and that is something to always be reviewed. Let's keep it bright so you can see things. Here we are. That will be our y-axis. This is the x-axis. Mark it. This is x. This is y. And now, just to get a feeling for the shape of the curve, let's plot a few points. Okay, a few ordered pairs as they are known. Let's do that using a different color here. I've got a whole palette of colors, so let's use, I don't even know what this one is. Okay. So let's do f of 0, of course, is e to the 0, which is 1. So here, to make things easy to read, keep the spacing big. Don't be afraid. Draw pictures, label things super clearly in the pictures, so that if anybody else had to look at your work, this person would know immediately what you mean. Okay? So, f of 0 is e to the 0, which is 1. Mark it here. Okay? And then, of course, don't forget to mark the x's. Some people use little lines. I use little dots, sometimes little lines. Whichever one you want to use. There we are. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. Do the same thing on the vertical. Mark those. Space them out so things are clear. Perfect. Okay, so that's our coordinate system. Now, when x is 0, as it is here, the value of the function is 1, so we can mark that. Okay, let's see. Let's mark that in this blue here. And then when x is 1, the value of the function is e to the first, which is e. That's about 2.7. Okay, so that's going to be a rough estimate here. But that's all we really need, a rough estimate of things. Maybe about here. Okay, and after that, we will pretend that we have never ever seen this function before, though I'm sure you have seen it before, and just extend it kind of, this way, right? This is our function. Okay, at least a piece of it. I'm focusing only on the positive portion, and it goes off to positive infinity. Okay, so we have just plotted this function. Now what we are going to do is find the slope and the inverse of this without knowing the inverse, or without knowing that the inverse is the ln function. We don't care about that. So first, how do we find the inverse just by looking at the picture? Without any mathematics, all you have to do is turn the page, look at the picture from this angle, as I'm doing now, okay, and then this becomes the inverse of the function. That's it. It's that simple. This is the inverse. Now you are treating y as the independent variable, and x, so to speak, as the dependent variable. You turn it, look at it from this perspective. Okay, the roles are switched between y and x, or x and y. That's it. Well, so we have this in place. What is the next step? Say somebody says, find me the following piece of information. F inverse at 4, and then the derivative. The value, in other words, of the derivative of f inverse at 4. We don't know what f inverse is. Pretend you don't know. We know it's ln, but pretend you don't know. And we are going to say the following, that this quantity here is simply equal to 1 over f prime at, and here comes the crucial step, the value of x that gives you 4 on the y-axis. So to get some feeling for that number before we do any mathematics whatsoever, take a look. This is the number here we are feeding into the inverse function. So to get back to the x that creates it, draw a little line this way, and then roughly shoot straight down to the x-axis, as I've done here. And this value of x that we hit over here is the value of x that creates that 4 that is going into the inverse. Okay? So we have to find that value. So the way to find it, of course, is formally what we can say here is f inverse f4, and close that within a parentheses as follows. Okay? And now, f inverse of 4 is asking you for that value of x that gives you 4. So you can trace the arrows back over here, and I am going to approximate this, and I'll do it exactly. This is just intuition, so you can develop some feeling for things. And notice that that number 4 is roughly between 1 and 2, so maybe 1.5. So we will approximate this as 1 over f prime at 1.5. And of course it happens that e to the x has the same derivative. So I can simply write now 1 over e to the 1.5. Which, and the rest is calculator work because these numbers are not very pretty, is the following. So first let's do e to the 1.5. That's the first step. Okay? And you can approximate, make things exact. That's entirely up to you. Okay, so 1.5 and e. So that gives about 1 over 4.5, and I'm keeping this really rough. And then 1 divided by that is about 0.22. So based on this, what we have found roughly is that the slope here is about 0.22. Okay? That's the slope of the inverse. And what we are looking at, remember, is from this perspective. Okay, this is a different perspective and the same concept. In other words, draw a little slope triangle at that point as I've done here. And then roughly, because the slope is 0.22, we can imagine that if that is about 1, then that is about 0.22. So that the slope is, the 0.22 divided by the 1. Okay? So there you go. This is how you find the slope on the inverse of a function without having to find the inverse. Notice that at no point did we use the inverse, right? We used only the function, and knowing its derivative, we're able to find the slope of the inverse at that value here, 4. Okay? And that is the procedure in general. So thank you for watching. Don't forget to smile and have an absolutely amazing day.